Hello, last part of our SAC. Experiment 3AB, which is a gaseous equilibrium system, which is the equilibrium between two gases. As you can see, the two gases are N2O4 and an NO2. Now, it is important to know that NO2 has got a color, which is a brown in color, N24 is colorless, right? Now, according to our observation, what has happened here, when the temperatures increase, the brown color, the intensity of the brown color has increased. That is to say, forward reaction has occurred. At high temperature, at high temperature, the forward reaction has occurred. So, why do you think why forward reaction is being happening? When you increase the temperature, system will partially oppose the change by trying to decrease the temperature. Trying to decrease the temperature, so system should favor the endothermic reaction. In this case, forward reaction has favored. Therefore, forward reaction is endothermic. Delta H is positive. So the reverse reaction is the exothermic reaction. Is that clear to you? Right? Okay, that's what has happened. When the system is cooled, as you can see, reverse reaction has favored because which is exothermic, and the color intensity, brown color intensity decreases. It is going to go towards the colorless side. When the volume is increased, you know that the concentration of all the component is the system. What are the all the gases in the system? In other words, both the N2O4 and NO2 concentration is going to decrease. That is why everything is going to become lighter. Then system will partially oppose the change by trying to increase the concentration. Therefore, system should favor the side with more particles, the forward reaction. Therefore, the intensity of the brown color will increase. It will become darker, but it is always going to be less darker than the change was made. Yeah, just before the change. So it's going to be less darker, right? Okay. By knowing that knowledge in our hand, I was meant to say, but having that knowledge, let's try to look at the question. All right. Now, first question is what? Going back. Sketch the graph. What would happen to the concentration of the reactant product when the N2O4 equilibrium system was cooled? Cooled. When it is cooled, system will partially oppose the change by trying to increase the temperature. It is better we write it down, the given equilibrium system, because otherwise you don't know what you are doing here. Okay, so this is delta H is negative positive. So when you cool it down, system will partially oppose the change by trying to increase the temperature. Therefore, system will favor the exothermic reaction, which is the reverse reaction. Which is the reverse reaction is the one which is exothermic, right? Then when reverse reaction is favored, N2O4 will increase. So let's say it is going to increase by 1. That's not good. Let's say it's going to be increased by 1 x. Then if this is x going to increase, this is plus x. Then the NO2 will go down by 2x. Yeah, it should go down by 2x minus 2x. Is that clear to you? Okay, that's simple. How did the volume change in exponent 3b affect the yield of NO2, nitrogen dioxide? Volume change. So what will happen when the volume is changed? Volume is changed. What did we do? Volume increase or decrease? Man, I have to go and check again. What? Light volume is increased, isn't it? So when the volume is increased, what will happen? Okay. Volume is increased, pressure will decrease. So system partially oppose the change by trying to increase the pressure. Therefore, system will favor the side with more particles. So the number of moles of NO2 will increase because forward reaction is being favored. Therefore, number of moles of NO2, which is the yield, will increase. So the number of moles of NO2 will increase because forward reaction is going to be favored. The yield is the question is asking you yield, right? Yield is the number of moles of NO2. That's the yield, the product. In this case, even though the concentration of NO2 will decrease, but the number of particles will increase. So number of moles will increase. Is that okay? That's the answer. So therefore, yield will increase. Yield will increase. So you can say volume is increased, pressure is decreased. According to the Le-Chatelier principle, system will partially oppose the change by trying to decrease the pressure. Increase the pressure. Therefore, system will favor the side with more particles. Yeah. So the forward reaction will be favored. Therefore, yield will increase. Yield will increase. Part B. Part B. What? Part B. When the syringe was extended. So, the same thing, isn't it? How the volume change in 3B? Yeah, it's the same thing. B. I don't know why they are repeating B. When the syringe was extended, the volume is increased. Then the volume is increased, then the concentration of both NO2 and N2O4 will decrease. Now, both will decrease. Therefore, now NO2 is the only species that has got a color. Therefore, intensity of the brown color immediately decreases. Immediately decreases, right? Then what will happen? System will partially oppose the change by trying to increase the concentration of the pressure. Therefore, system will favor the net forward reaction. Then the brown color will, the intensity of the brown color will increase again. Because system is now favoring the forward reaction. But then again, you have to say brown color will increase, but lighter than the original, lighter than the original before the change. Lighter than the original before the change. What I'm trying to say is this. Okay, now just before you make the change, there is a brown color. It is still lighter. Then the current brown color is still lighter than the original brown color. Yeah. Okay. If I want to draw a time concentration graph, let me do that. NO2 concentration, right? This is equilibrium. NO2 concentration doesn't change, so it's brown, right? Now you are increasing the volume, then the brown color intensity decreases. Look, concentration decreases me. The intensity of the brown color decreases. This is lighter. After that, you know that this is T0. This is T1. At T1, what will happen? System will favor in the forward reaction. So NO2 will still increase. No, NO2 concentration will increase. But as you can see, it is still lower than the original color. That's what I was trying to say. Okay. Now Okay. Question 12. Question 12 is asking, what is it asking? Position of the equilibrium. Position of the equilibrium. Now, okay, it's no effect. We know that because why? Because neon will not react with. Neon is inert. Inert. It is not a reactant. It does not react with any of the. It does not. Doesn't react with. It doesn't react with either NO2 or N2O4. Either NO2 or N2O4. So concentrations are therefore concentration NO2 concentration or N2O4 concentration not affected. Concentration not affected means what? And not affected means position of the equilibrium is not changed. It's not changed. Simple. All right, we finished this sack. I'm going to upload it. Nostrils. Can you please make sure you go over these things, okay? I wish you all the best for tomorrow. And do your best. And read the questions. Okay? All right. Talk to you soon. Bye.